Hello, my name is Raj and currently here to present the work of development of low-cost difficult equipment with the authors Fredetirio, Jorge, and these others. I'm currently engineering mechatronics students under the degree, and I will present here a little bit about more details about the equipment. So when we talk about the difficult process, the principal goal is to obtain thin films. The application of this process is more visible on the part of the production of the rear mirrors or the glass anti-reflective, and we have as advantage the low cost, the versatility, and the high quality of the films produced. When we saw about the equipment that we use for developing this kind of films, we saw a little some parts that are hard for developing this kind of films, which is related for the price range, which it is based on 2,500 dollars until $7,000. And here on Brazil, equipments we will start by 5,000 of reais. The objective of this work is to present a little bit about the results of build a difficult equipment with low-cost components and the open source hardware. And here we can see a little bit about how it is the process, but we will see a little bit about how it works on the next slides. If we start to look a little more about what are the works that we have related for the use of automation in the Arduino in the chemical area, we found some works like the work provided by Oliveira Zarbin, like present here, that he have the goal of using recycled materials to build a difficult equipment. Or we have also the project of Alves that have the goal of develop the direct bench for the production of biodiesel oil with Arduino. And the other work that we found also was the work of Tapia and the development of spin coat equipment using Arduino. And we deep a little bit about the difficulty process. We have 5 stages. The 5 stages are the immersion, where we have the immersion of the substrate here, like this part, in the solution at a constant speed. On next, we have the commission. The substrate it is on the solution for a specific time by the user, by the operator. On next, we have the deposition. The thin film is deposited on the substrate when it's removed. And on next, we have the drainage. So the excess fluid drains from the surface, or on last end the evaporation. The solvent evaporates from liquid, forming a thin film. And on this figure here, we can see a little bit how it is a commercial product relates for the code process. This is an example of equipment that it is on the price range that we mentioned previously in dollars. And for this kind of development, we use 2 motors named as 17 with a voltage of 5.96 volts and a steep angle of 1.8 degree. We use it has also a nominal speed of 1,000 rotation per minute. And on next, we have the use of 2 A4988 drivers because we need the interface between the motors and the Arduino or the microcontroller. These drivers have the power supply in the range of 2 until 37 volts, and the possibility of selecting different microchip options between 1/1 and 1/16 that will change a little bit about how smooth will be the functionality of the motor, right? And as prototype board, we use Arduino and LM2596 step down to convert the power supply that provide for us 12 volts into 5.96 volts that it is related for the power supply that the motor needs. And here we can see a little bit about all the interface, all the different components, like the driver, like the motor, like the LM2596, the limit switches also that it is needed for we show for the equipment that present for us a limit about the upward movements and downward movements, the power supply, the Arduino here. And when we saw a little bit about the flow of execution of the experiment, we have on a first moment the input of the variables like speed of centimeters/minute for the downward and the upward movement. On next, we have the time of the immersion of the solution related for the process that we mentioned previously. The serial communication will happen between the computer and the Arduino at the moment. And after the inputs of the variables that it is made between the computer and the Arduino, the microcontroller, we go next for the part of have a movement of the platform upward until it reaches the limit switch on the top of the prototype. And on next, we have the execution of the downward movements of the motors until it reaches the displacement position defined with the speed set by the user, right? By the end, we will have the delay of the movement execution based on the predicted time. So what is the time that we have that we need that the solvent will be on the substrate? This is related for this part. And on the next, we will have the execution of the movement of the motors on the way up with predetermined speed and position. And on this part, we can see also a little bit about the different components, the different parts that we need for all this equipment. So we have here the trapezoidal axis, we will have the stippy motor, we will have here also the support for claw attachment for substrate fitting, the table for the beaker where we have the solution, and also some 3D printed parts that it is related for fitting nuts, linear bearings, so make possible that this part will have the displacement and movements upward and downward on the ZX. And on next, I will show for you a little bit about how this equipment works. So we can see right now a little bit about the semi. And if we see, for example, here, we will have a stippy motor, this stippy motor, that it is doing a downward movement after the switches was having this high signal. And on next, he will do a downward movement until the point that the user wants that it relates for this part. On next, he will stop. It will stay a little bit with a delay because it is the moment where we have this substrate immersion and his immersion on the solution. And the next we will have the upward movements. We have here the power supply, the notebook as human interface machine to the difficult equipment. And on the next, we will have the end of all the functionality of this equipment. And as conclusion, we can see that we have a viability in building a low cost difficult equipment because it was not present on the article, but we spent like 1,000 of reais, so something like $200 compared for the part of the other price range that we saw, so it's viable, and we got some very good results about the equipment. But we have next steps also for this project because we need the creation of, for example, a shield that aggregates the electronics components like the driver, like the LM2596. Creation of a graphic interface like SCADA to build a human interface machine to increase usability and avoid, for example, the needs of your computer, so make it possible that you can use it on the equipment. And here we have the reference, and I want to say thank you by the opportunity.